Hi guys, this is Snow. In this video, I will talk about the rendering performance of our 2D game and introduce a way to improve it. So in the first half of the tutorial, we only draw tiles, few objects, player character, and UI. But we're gonna handle a bit more heavy stuff in the second half. So I think it's a good idea to optimize our code a little bit. So first let's check how long our program is taking to draw stuff. So this is debug stuff. First long draw start equals 0. Draw start equal system.nanotime. So again, we're gonna use this system.nanotime to check the time. Then after drawing these components, long draw end system.nanotime and past equal draw end minus draw start. And let's display past time on the screen. So g2 dot set color dot white, g2 dot draw string and draw time plus past, and x is I don't know, 10, and y is 400. And also I wanna display this on the console too. Draw time past, something like this. So this way we can check how much time has passed and display the time on the screen. And since this is a debug function, so I think it would be better if we can switch on and off. So open this key handler, debug, and I'm gonna use T as a shortcut key. Also, we're gonna create a boolean. This is also debug. Check draw time or something. Go false. So if check draw time equal false, then check draw time equal true, and else if check draw time equal true, check draw time equal false. And then so we only check this time if key h dot check draw time equal true. Put this inside of this if, also this one too. Okay, like this. Let's check. So if you press T key, so it shows the time. Yeah, like this. So now we can see how long this is taking to draw stuff during each loop. In my case, it is taking about from fastest is like 622,000 nanoseconds to yeah, like 700 or 900 sometimes. So that means 1 billion 0.0007 seconds. Not bad, but I think this time changes depending on the computer. So if there is a way to decrease this time, we better do that. So in my UI tutorial, I said you shouldn't create a new instance in game loop unless it's really necessary. And there is another thing that we can prepare beforehand. That is scaling. So every time we draw tiles or sprites, we type this width and height, so the image is displayed as a scaled size. So this image scaling is a pretty convenient function of graphics or graphics 2D, but it also takes a little time. So let's scale these images beforehand so graphics 2D can skip this process. So we're gonna scale these tile images when we import them. So basically this is how to scale buffered image, and first I will show you step by step. So for example, if we want to scale this image, we type like this, buffered image scaled image equal new buffered image. So gp.tilesize, gp.tilesize, and the tile 0.image get type, and import buffered image, and graphics 2D g2 equal scaled image dot create graphics, then the g2 dot draw image tile 0 dot image 0 0 gp dot tile size, gp dot tile size, and null tile 0 dot image equal scaled image. Yeah, this is basically it. So first we instantiate this buffered image. So this is basically like a blank canvas, and so when you instantiate it, you pass its width and height and image type. And the next line, this line basically means whatever this G2 is gonna draw will be saved in this scaled image. So in the next line, this G2 draw this image with this size, scaled size. And so the scaled image will be saved in this scaled image. Yeah, that's how it is. So if we repeat this to these other tiles, then we can scale everything. But typing these lines for every tile is kind of too much pain and not so efficient. So let's do a little housekeeping and optimize this code a little bit. So we're gonna create a new class and let it scale all these buffered images. So in this main package, create a new class, and I'm gonna name this utility tool. You know, this is like a toolbox class. So whenever you come up with some convenient function, you put it in this class and you can call it. Okay, public buffered image scale image, and we're gonna receive buffered image original and width and height. Import, I think. And basically we can paste it here and change this to width height original, and the draw image is original width height, and finally we return this scaled image. Oh no. Okay, and I think we should dispose this 2, I think. Okay, so something like this. And we just need to pass the buffered image and the width and height. So go back to this tile manager, delete this, and do a little reconstruction. First, we create a method called setup. And here we get integer index and a string, image path, and boolean called region. Let's instantiate this utility tool, utool, new utility tool. And then try and catch. What is happening? Utility. Okay, and inside of this try and catch, we're gonna instantiate new tile. Let's copy this. Change this to index, and also this part. So this part is different, but these parts are always the same, so we don't need to change it. Plus, what is it? Image path, like this, and then tile index dot image equal utool dot scale image. We're gonna pass buffered image and width and height. So tile dot index dot image, and width is gp dot tile size, gp dot tile size, and finally index dot co-region equal co-region. Yeah, that's it. So instead of these lines, we just type setup index and file name grass and collision status false. So we don't need this anymore. Okay, so let's copy this, and 1, 2, 3, 4, 5, 3, 4, 5, and index 1 is wall, water. True. Yeah, something like this. So we don't need this anymore. And try and catch too. We don't need these. Yeah, like this. So we pass index, image name, file image path, or image path, or more like an image name. Yeah, let's change this. Image name. So image name and the collision. So get instantiate tile and import the image, and also call this utility tool and get the scaled image, and also set the collision. So yeah, I think this looks more, I don't know, this looks better. So now all these images are scaled. So go to this draw method and delete these width and height. So this doesn't need to scale the image during the game loop anymore. And we do the same to player image and object image. So, and for player images, we are not using arrays like background tiles. So I think we only need to get the resource and scale it. So I think we're gonna just return buffered image. So set up and get image name. So it will be something like this. Utility tool, utility tool, buffered image, scaled image equal null, and try and catch. IO exception E. Scaled image io.read. Now let's copy this. Image name. Wait, no. And then scale the image equal utool dot scale image. Yeah, this I feel this is a bit strange. We are calling this scaled image before scaling it. I know it works, but somehow I don't like this. So let's change to image, just image. I feel better this way for some reason. And finally we return this image. Alright, so then we get this image. So this time we are not using array, so up1 equal setup and pass this name. This time we are only passing the image name since we don't have index, and also we don't need to set collision. So right, 1, 2, 3, 4. Okay, so we don't need these lines anymore. And okay, go to draw method and okay, delete these width and height. And finally object. So first open this super object and instantiate this utility tool. And then open object class. And for this one, I think we're gonna just call this utility tool and scale the image. Utool dot scale image and image RGB dot tile size. But yeah, I think we need a game panel. Yeah, so we get it from here. Game panel GP game panel GP. And okay, so let's add this to other objects. And okay, so and also yeah, go to this asset setter, and so when we instantiate this object we pass this GP. And what is this UI class? Okay, this one, GP. That's it. Yeah, so let's check. Okay, and let's show the draw time. Okay, so now draw time is something like this. So it's like between 430,000 to 650 or something. So I think the draw time decreases by, I don't know, maybe 200,000 nanoseconds or something. For now, it's not a big difference. But when you use more tiles, draw more stuff on the screen, this difference, this kind of optimization creates will become pretty significant. Yeah, so before moving on to the second half, I wanted to introduce this little method. Yeah, that's it. So I hope this was useful for you. Thanks for watching.